Hello. I was hoping to give you a little bit of help or some just friendly reminders and pointers that might help you through some of these Conic applications problems from your WebAssign Conic apps problem set. I'm looking through the first couple pages, actually just the second question, and these are based off of questions I've already gotten from your classmates, and I'm thinking it might help everybody. What did you catch in number 2 that might be a little tricky? So if you haven't caught it yet, this problem's not bad to just model the way they say to. So just draw a parabola that has a vertex at the origin. And it makes getting your model pretty quick too, that it's an x minus nothing squared, since your vertex is at 0, 0, equals 4p. We are vertically oriented, so y minus nothing, like that. But what is going to get me? You are 80 feet long, this beam, so I know this is over 40 feet for your x coordinate, but are you up 1 foot for your y coordinate? There's a mixture of units here, right? It says the center, the deflection of the beam at the center is 1 inch. So that's 1/12 of a foot. So if you're thinking good next step would be to do a plug-in of the coordinates to help you get P and get this equation, remember in part A to call this 1/12 of a foot, and in part B, it says how far from the center of the beam is the deflection of 1/2 inch. Do this whole problem in feet. Call it 1/24 of a foot before you do your plug-in. All right, so that's a tip on 2. The next question was on number 8. And it was about an ellipse, I think an elliptical orbit of a comet. And remember, my numbers that are in red are going to be different from your constants. I'm hoping it went okay to find a model. I'm just going to start at A just to make sure we're on the same page about this question. Go sentence by sentence. Elliptical orbit, center of the sun is at one focus. The eccentricity is about 0.987. So I'm going to use what I know about eccentricity, and I know that eccentricity equals C over A, that ratio. So I can write that C over A is going to equal 0.987. I think my best bet is to use this side over here. So C over A equals 0.987. That's going to help me. If I know one of these things, I can get the other one. Oh, look, the length of the major axis is about 30/4. So the whole major axis is that many astronomical units. So A is going to be half of that. A is going to be half of 34.17, so 17.085. Circle that so we don't lose it. And that automatically gets us C. It's not that I need C right now to get the answer to part A, but it might help me at the bottom of the page, so why not, right? C over 17.085, sorry for the sloppiness there, equals 0.987. Solve that for C, you get C equals 16.863. Approximately. All right, so I've got 2 of the 3. I can see, oh, I didn't even realize the answer was sitting here. Okay, well, A squared is going to go here, right? So this will be 291.9 is going to be 17.085 squared. How did they get this number here with my constant units? Well, I know A and C, and I know this is an ellipse, so I can use A squared, 17.085 squared, equals B squared plus C squared plus 16.863 squared. So that's not too bad either. You get B squared, apparently, since the answer is sitting right in front of me, is going to equal 7.54. So that's good. Now you have an equation. You can easily get a graph now if you think about how many units you have to go roughly out and over. In my case, I think it was the 4th graph that worked pretty well. And then lastly, part C, it says, how do we get these 2 answers? And your numbers are going to be slightly different. Can you find the greatest and the least distances? So in astronomical talk, you call it the aphelion and perihelion, respectively, from the sun's center to the comet's center. This is going to help us in the very next question too, so might as well go over it. Think about it. You've got an ellipse, and the sun is always going to fall at one of the 2 foci along the major axis there. The furthest that the comet can be from the sun is when the sun is here and the comet is all the way over here at that vertex of the ellipse. Comet, I'll put com for comet, and then sun. So this whole distance here is going to be the far one, the aphelion. I'll just put ap here to here. Well, think about it. That is going to be, you could add from here to there, we could add A to C. A is this whole distance here, right? Plus C, which is center to focus. So to get this first answer, you're going to add A and C. That is the greatest distance the comet could be away from one of the foci. the closest it could be is if the comet's here and the sun is at this focus. This is the shortest distance right there. And it's going to be all of A take away all of C. Whew, messed that up there. So A minus C actually is going to be the closest it could be. We're going to use that, like I said, in the very next problem. So I just used the A and C from the numbers that I got above. 9 is a problem that is my least favorite on this entire assignment. I'm going to help you get through it, and it's not really one that needs to be a big focus of your studying. Same idea, though. It's a good follow-up. This time it's a satellite orbiting the Earth, and the center of the Earth remains at one of the two foci. So kind of like the last question with the sun being at one of the two foci around where that comet is going. So for this one, I guess I have what the answer is supposed to be here. Can we use what's given in the problem? So we'll say in this one, it tells us the furthest away that the satellite could be and then the closest the satellite could be if we add a couple numbers there. So the furthest away the satellite could be, so the aphelion from the last problem, would be A plus C. A plus C is going to equal the radius of the Earth plus that 939 kilometers in my problem. So it'll equal, radius of the Earth is about 6,378 kilometers plus 939. And you get A plus C equals, in my case, the number 6593. Keep that in mind. Okay. The closest this satellite can be to the center of the Earth is, it talks about over here, only 215 kilometers away from the outside of the Earth. So it's going to be the radius of the Earth plus the 215. So the closest the comet could be is perihelion A minus C. A minus C is going to equal radius of the Earth minus, in this case, plus, still plus, and then the 215 instead of the 939. And you get A minus C equals, we add those up, and you get 65. Oh, I did the first one wrong. Okay, so this one, I'm sorry, 6593 is this one. I was just looking at the wrong spot on my paper. And then you might have already noticed that the A plus 3 has to be bigger than that, 7317. I want to leave it to you. I want you to take this equation and that equation and just solve them as a system. So set one of those sums equal to A minus C, set another sum equal to A plus C. It'll help you get A and C, and your answer is going to be C over A, like that. To get the eccentricity. Again, not the most important question on this sheet. The next question was about the very last problem, and before I go, we have to talk about number 13. Toughest problem on the entire WebAssign, I would say, and also my favorite. My favorite problem on the whole entire thing. Takes a lot of good thought here. So let's look. It says you have a hyperbolic mirror where it's used in some telescopes where a light ray directed at focus A is reflected to focus B, like you see in the figure. Find the vertex of the mirror when its mount at the top edge of the mirror has coordinates 24, 24. So this is unlike a hyperbolic question that we've seen before. Usually we have a little bit of information about what A and or B might be, but here we just have C and a point that's on the hyperbola. You gotta buckle your seatbelts, boys and girls, because we're gonna have a lot of algebra to do in this question, but it's a good one. So right now, I could start constructing the equation of a hyperbola because I look here in the way that it's modeled, we're right on the origin and we are oriented horizontally. So I know x squared is a numerator, x minus 0 squared, y minus 0 squared is the other one, minus because it's a hyperbola, and let's keep the x fraction positive. On the bottom are two things that you don't know, a squared and b squared. And now we got to see how we could use c to help out with that. Right now, plugging in 24, 24, these coordinates for that x and y, it's a common thing for us to do, just plug in the point, is not going to do us much good. You're still going to have the two unknowns. If we could both use the 24, 24, and also either get a in terms of b or b in terms of a, then we'll only have one variable, and this will be solvable. So do it. You know with the hyperbola, c squared equals a squared plus b squared. And we know c squared. We know center to focus is 24 units. So 24 squared equals a squared plus b squared. Use it. I think we'll get this whole problem in terms of a. So let's go 24 squared minus a squared equals b squared. And this is going to get plugged into that just to get rid of one of the variables. So let's write it. X squared over a squared minus y squared over this expression, 24 squared minus a squared equals 1. And now we have a good bit of work to do. Let's do the plug-in. So plug in 24, 24, the coordinates of the point that we know this hyperbola goes through. So now a lot of 24s in the question. 24 squared over a squared minus 24 squared over 24 squared minus a squared equals 1. And pick your best favorite way to solve. I tried it once where I moved this fraction over to the other side. It was easy to combine it with a 1, and then I multiplied both sides by the denominators. If you see, you could easily just combine these fractions now. This is where all your expertise with simplifying rational expressions comes in handy. We could get a common denominator, 24 squared minus a squared, and give each fraction what it needs. So the 24 squared was missing 24 squared minus a squared, minus this, which would be joined by an a squared, 24 squared, a squared, like that. So this is just getting common denominator, writing this as one singular rational expression, equals 1. That's kind of nice that you have that on the other side. Now get ready for the numbers to get real big. 24 squared is 576. And I think now is the time to multiply through. So you're going to have 576 times 576, and you're going to get 3, and I knew there was a 1776 in there, right? Great year for the US. 331776. That's 24 squared times 24 squared minus 24a squared minus 24 squared a squared, so 576a squared. All that up top. On the bottom, I guess we could also get rid of the parentheses. So you have 24 squared times a squared, 576a squared, minus a to the 4th. We are dealing with a quadratic function. Now we can multiply both sides by that denominator and try to combine the like terms. So you have 31776 minus 24a squared. And I guess I forgot the squared here. That should be a 576, shouldn't it, right? That 24 squared should have come through. And then minus another 576a squared equals, this times 1, so 576a to the a squared minus a to the 4th. And I want to be really careful now. I don't want to make any other careless mistakes. This is, why don't we move everything to the left-hand side? So a to the 4th is going to come over positive. How much a squared do you have? So you have minus, this is 576, a squared, minus another 576 a squared. So that's 2 of those. And then we're going to subtract a third one. So on this side, when you simplify, you should get minus, I think maybe Fetty Wap sang a song about it, 1728, if I remember the lyrics correctly, a squared. So try that. And do I have a constant? The constant is that big number, 331776 equals 0. So when's the last time you solved a quadratic function without graphing on a calculator? Today's going to be the day. We can treat this in a quadratic form and use quadratic formula. The answer that we're going to get isn't going to be a, it's going to be a squared. But we can still use the same a, b, and c as in quadratic formula. So opposite of b, 1728, plus or minus square root of, I'll just write 1728 squared, and then minus 4 times 331776, like that, all over 2. And you're going to get 2 values for this. This is where I just typed into the calculator, took the easy way out. I get that either a squared is about, I think 1507.988, or a squared is about 220. One of these answers actually has to get thrown out. If A is just roughly around 38.83, that's too big. That's outside of the hyperbola, outside of the focus. This one I think will be just right. To the nearest hundredth, approximately 14.83. So your vertex has this x coordinate. That's what A is going to be. Vertex, it'll be about 14.83, 0. Hope that was enjoyable and you enjoy the rest of your day. All right, keep solving.